Today chapter D and F block element. T elements means what? And transitional elements. D block element is the transitional element. F block element is the inner transitional element. And you already know some concept and how is the calculate the magnetic moment. How is the magnetic moment is produced. You already know about it. And the magnetic field of the strength is H, capital letter H. How it is the magnetic field of the H is produced. Any one substance when placed in a magnetic field is strongly attracted by the magnetic field, that is called the magnetic field of the strength is H. For example, the iron is placed in a magnetic field. It is very strongly attracted by the magnetic field, that is the magnetic field of the strength of the H iron. Okay, that one is the example. The iron is the very good magnetic field of the strength H and the magnetic field. Okay, very good of the magnetic field. Then is gone that and ferromagnetic. You already know about it. And ferromagnetic. Ferromagnetic is how it is produced. How it is that. For example, the ferromagnetic is the example is given that in the iron. The magnetic field of the iron. Magnetic field. Magnetic field. The magnetic field of the in the iron very greater than H, very greater than the H. That is called that in the ferromagnetic. Ferromagnetic means is the magnetic field in the iron is a very greater than is H is called that in the ferromagnetic. Next is go on the paramagnetic. Paramagnetic. Paramagnetic is example is taken and Cu2 plus and it is not is a very smart term and magnetic field in the Cu2 plus is the greater than the H is called that in the paramagnetic. Next is go on the diamagnetic. Diamagnetic. How it is the diamagnetic? Example H2O. H2O is the less than H is called that in the diamagnetic. You already know about it. And ferromagnetic is the permanent magnet and paramagnetic is called in the temporary magnet and diamagnetic is the and very small amount of the magnetic field or absence of the magnetic field. You already know about it. And diamagnetic and paramagnetic, ferromagnetic. How it is the magnetic moment is produced. Magnetic moment is produced in the two ways. One is the spinning of the electrons about it is the one axis. Spinning of the electrons about it is the one axis is the magnetic moment is produced. Another one, the motion of the electrons around the nucleus and produced in the magnetic moment. Two reasons the magnetic moment is produced. One is the spinning of the electrons about it is the one axis. Another one is the electrons is the traveling of the nearest around the nucleus to the produced in the magnetic moment. Magnetic moment. Then how it is the magnetic moment is produced? He said and number of unpaired electrons is increases, magnetic moment also increases. Simply say and increases of the unpaired electrons, the magnetic moment also increases. Is given that in the formula the magnetic moment is the formula is there and mu is equal to square root of n plus 2 and Bohr magneton. This is the magnetic moment is the formula. And for example and example is taken on to scandium. Scandium, you already know what is the atomic number 21. Atomic number is 21. What is the electronic configuration? Scandium and 1s2, 2s2, 2p6, 3s2, 3p6 and then after that 4x and 3d10, 3d1, 4s2. This is the inner shell. What you call this is the inner shell and this is what you call outer shell. Outer shell. Simply and write organ. Organ is what is atomic number is 20. 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus and 4, then after that 18, 2 plus 2, 4, 4 plus 6, 10, 12, 12 plus 6, 18, 18 plus this one is come 19, 20, 21. This is the organ is the, what is the atomic number organ? It is come 18. Then we should write down 3d1 4s2. This is 3d1 4s2. The scandium, they calculate the magnetic moment. Calculate the magnetic moment. Scandium 3 plus. Scandium 3 plus. You already know what this is the scandium. And scandium 3 plus. 3 plus is indicates what? 3 electron losses. Organ. And 3d0 4s0. 3d0 4s0. Scandium is the orbitals of the scandiums. Orbitals of the scandium 3 plus. 1, 2, 3, 4, 5. And 1. No unpaired electrons and no electrons. And n is equal to, n is indicates what? N is indicates the number of unpaired electrons. Number of unpaired electrons. Number of unpaired electrons. N is indicates number of unpaired electrons. No is there unpaired electrons, it is only empty orbital. Therefore, n is equal to 0. The mu is equal to the molecular formula. This one is the n and n plus 2. And Bohr magneton, and the number of unpaired electrons is 0, 0 and 0 plus 2. Answer is the Bohr magneton, it is the 0. Scandium 3 plus. And no unpaired electrons, the magnetic moment is come, and the scandium 3 plus is the 0 of the magnetic moment. Then is gone the manganese, Mn2 plus. Mn2 plus. Manganese. What is that? In the manganese is the atomic number. Manganese is atomic number 25. Atomic number is 25. And manganese is organ. You already know what is the atomic number organ. Inner shell 18. Then 3d5 4s2. 3d5 4s2. 18. 18 plus 20. 20. 25. And orbitals Mn2 plus. How many electron losses here? Organ 3d5 4s0. 3d5 4s0. And orbitals of Mn2 plus 2, 3, 4. And this one 1, 2, 3, 4, 5. And 5 unpaired electrons. Orbitals, this is the 3d5 and this one is the 4s0. Number of unpaired electrons is how much here? Number of unpaired electrons is 5. 1, 2, 3, 4, 5. Number of unpaired electrons is the 5. Number of unpaired electrons is 5. The 5. 5 and 5 plus 2. 5 plus 2. And this is the 5 plus 2, 7. 7. 7 5 is 35. 7 5 is 35. Square root of 35. What is the square root of 35? And it is come, and 5 point is come 5.91. This is the 5.91 is the Bohr magnet. Listening here, it is the calculate the magnetic moment Mn2 plus, and mu is equal to square root of n plus 2. Bohr magneton number n is indicates the number of unpaired electrons. Manganese, what is the atomic number? 25. Mn organ 3d5 4s2. Mn2 plus, how many electron losses? 2 electron losses, and organ 3d5 4s0. Then orbitals of Mn2 plus. Orbitals of the Mn2 plus 1, 2, 3, 4, 5. 5 unpaired electrons. Then 4s0. 4s0. Why? Because 2 electron losses already. This one. And 4s0. Then number of unpaired electrons is how much here? 5. 1, 2, 3, 4, 5. 5 plus 5 and 5 plus 2, 7. 7 5 is 35. Square root of 35 is come 5.91. You already know the magnetic moment is when it is increases, number of unpaired electrons is increases. Number of unpaired electrons increases, the magnetic moment also increases. Next is go on zinc 2 plus. Zinc 2 plus. Zinc 2 plus. Zinc is what? Atomic number is 30. And how many electrons is there? Zinc 2 plus. What is the electronic configuration? Organ 3d10 4s2. 3d10 4s2. And how many electrons is losses? Ions. And zinc 2 plus. Organ 3d10 4s0. Then orbitals of zinc 2 plus ion 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the 3d10 and this one is the 4s0. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total is come 3d10. No unpaired electrons. Here, no unpaired electrons. Therefore, n is equal to 0. The mu is equal to no unpaired electrons, square root of 0 and 0 plus 2. Answer is come 0. 0 and 0 and 0 plus 2. 0. 0 plus 2 is come and both magneton answer is come 0. 0 into 2 0. Okay. And no unpaired electrons, zinc 2 plus here. And always fully paired is there, therefore is the no unpaired electrons, n is equal to 0 and 0, 0 plus 2, 0 into 2, 0, zinc 2 plus. Then is go on Cu2 plus. Calculate the magnetic moment. Cu2 plus. Calculate the magnetic moment is the Cu2 plus. Copper, the mu is equal first square root of m and m plus 2. Bore magneton. Copper is what is the atomic number? 29. And copper organ, you already know 18 this one and this one 3d10 4s1. Organ 18, 18 plus 9, 19, 19 plus 20, 29. Orbitals and the Cu2 plus, how many here? Cu2 plus organ 3d9 4s0. 3d9 4s0. Orbitals of Cu2 plus 3d9 this one 4s0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Only one unpaired electrons here. Total is come 3d9 here. 3d9 4s0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Total is the one unpaired electrons, n is equal to no. And no paired, only one unpaired electron, n is equal to 1. The mu is equal to square root of 1 and 1 plus 2. The Bohr magneton, the mu is equal to 1 into 3. The Bohr magneton, the square root of 3 is equal to 1.73 Bohr. This is the calculate the magnetic moment. This is very very important, and for the annual examination, the board examination, you already know scandium 3 plus is come, and 3 plus is the no unpaired electrons, the 0. Answer is come to that 0 magnetic moment. Then is go on the manganese. The manganese is come and 5 Mn2 plus. Calculate the magnetic moment is come. Mn2 plus is the and 5 unpaired electrons is come. Answer is come 5.91. You already know. And increases of the magnetic moment, increases of the number of unpaired electrons that present in the d subshell. Then after that d subshell and other also is come. Then and zinc 2 plus is gone. Zinc 2 plus what? And number of no unpaired electrons always is a fully paired. N is equal to 0 and no unpaired electrons, therefore and 0 magnetic moment. Then another one is gone, the Cu2 plus and number of unpaired electrons here only one unpaired electrons, the v is equal to 1 plus and square root of, and square root of 3 is come, answer is come 1.73. This is the magnetic moment. The magnetic moment is how it is produced, and the spinning of the electrons about it is the one axis. Another one, the magnetic moment is produced, electrons is traveling in around the nucleus, the electrons is motion around the nucleus, to be magnetic moment is produced, simply say that one. Then you already know the magnetic susceptibility. Magnetic susceptibility means is the measure the how much of the substance is the magnetized, the present in a magnetic field is called the magnetic susceptibility, means how much is the magnetic field is produced in the particular substance, that is called the magnetic susceptibility, that one. Okay, and you already know this is the magnetic moment is how it is produced. Simply say number of unpaired electrons is there, and spinning of the electrons about it is one axis. Another one, the motion of the electrons around the nucleus. This is the formula of the calculate the magnetic moment, and square root of n and n plus 2 over magnet n, and n is indicate is what, number of unpaired